Hi everyone, in this video lecture we will see something about thread synchronization. Before we deal with thread synchronization, we will see what is this join method. So we have seen so many methods inside the class thread, and we have explained what's the purpose of each of those methods. One among the most commonly used method is join. So join method actually it is used for waiting for a thread to die. That means if you are calling this method by using a thread, then this method will wait as long as that thread is alive. That's the purpose of this method join. So this join method waits for a thread to die. That means it will not let other threads to work when the current thread on which this method is invoked is alive. And there are two ways in which we can call this method. One is simply without any parameter. The other way is by calling this method by sending one parameter which is of type long, and we are saying that the thread will be joining after this much milliseconds. In both of these cases, this join method throws the interrupted exception. That is, when a thread have called this method and if any interrupt occurs, then this method will throw the interrupted exception. We will see one example, and whenever you are asked to create a thread, you have to keep in mind what we have to do is we have to create a class that extends the thread class or that implements the runnable interface. In the previous video lecture, we have seen how to create threads. We can create threads in two ways, either by extending a thread class or by implementing the runnable interface. Any of these two ways we can use. So here in this example, I have used the inheritance property. That is, I have created a thread by extending the thread class. Okay, and we know that this is the method in which we have to write our logic. That is, it is the run method that gets executed when we start our thread. So we have to write all lines of code that our thread have to perform inside this method run. And we know what is sleep. Sleep is used for temporarily stopping the thread for some milliseconds. The parameter we give to this method sleep is in terms of milliseconds. And see, inside the main method I have created three threads, T1, T2, T3. So how to create threads? Just create the object of the class which extended the thread class, because now test join method 1 is actually a subclass of class thread. Why? Because of this inheritance property. So since this test join method 1 is actually a subclass of thread, it is a thread itself. So for creating thread, just inherit the thread class or just implement the runnable interface, then create the object of the class. Thus we are creating the threads here in the example. So here T1, T2 and T3 are threads. Now see what I am going to do. I am starting the thread T1 by calling the method start. So when this method is invoked, actually it is going to execute the method run, because we have seen start method is the entry point for the run method. So whenever we call the start method, it's actually the run method that gets executed. So when T1.start is this line is executed, the run method of T1 starts working. So here the for loop will work and thread will sleep for 500 milliseconds. But here I have called T1.join. So what happens is, even if this thread will sleep for 500 milliseconds, since we have called the join method for T1, join method will wait until T1 is dead. That is, until T1 completes its execution. The join method will not allow the other threads T2 and T3 to start, because we have called T1.join. So you can see the output here. We are printing 1, 2, 3, 4 and 5. These 5 values belongs to T1. See, we are printing here system.out.println I. So starting from 1, 2, 3 and 4 and 5, those values will be of thread T1. After that, after that the loop gets terminated, that means our thread T1 stops. Okay, so T1 dot join will release the control, then after that T2 and T3 will start. So then you can see how the output is getting printed. 1 1, this is of T2, this is of T3, this is of T2, this is of T3. So earlier it was not like that. We got the continuous values because we have called T1.join. Since we have called T1.join, the join method will wait until this T1 is dead. That is why we are getting the output like 1, 2, 3, 4 and 5 continuously, because all these 5 values are of thread T1. I hope you understood. Next we will see about Java thread synchronization. So what's the need of synchronization? First of all, we know that when there are more than one thread inside a program, so threads are actually lightweight processes that we know. Threads are actually part of the same program or same process. So when there are multiple threads and if they share a common resource, for example, in our program there are 3 threads and all these 3 threads make use of a single file. So it will lead to data inconsistency. For example, one thread may be reading the file. At that time, another thread may write the contents into the same file. So since one thread is reading the file and the thread is writing the file, data becomes inconsistent. So in order to prevent that, we need to perform synchronization. Okay, now how to perform thread synchronization? For that there is one concept named monitor. Okay, so monitors are like a lock. That means only one thread can access the content inside the monitor at a time. So what we are going to do is we are going to place the content that is being shared by the threads inside a monitor. So for example, if we have a file that is being shared by 3 threads, we will keep that file inside a monitor. So only one thread at a time can access the file inside this monitor. So if currently a thread is accessing that file and if another thread comes to access that same file, then the thread that came will have to wait as long as the current thread finishes its executing. That is how we are going to do. Now to implement this monitor concept, we can do it in 2 ways, either by using a synchronized method or by using a synchronized block. So what is synchronized method? Synchronized method is just a normal method, but we'll be using the keyword synchronized just before the method name. So to make a method synchronized, what we have to do is we have to use the keyword synchronized before the method name. Once a method is declared as synchronized, only one thread will be able to access it at a time. Similarly, synchronized block means we know how to create blocks in Java. Blocks means it's a pair of curly brackets. So synchronized block means we will name the block by using the keyword synchronized. So once a block is declared as synchronized, only one thread can be inside that block at a time. We will see an example, then it will be more clear to you. So this example is that of a synchronized method. So here I have created 3 classes. So class print demo, class thread demo and test thread. So here which class is the thread actually? Thread demo is the thread because this is the class which extends the class thread. So thread demo is the thread actually. And so if you have to create threads, we have to create objects of this class. So see, we have created 2 threads, T1 and T2. Both of them are objects of class thread demo. So now these two threads T1 and T2 are going to access a common method that is inside the class print demo. So what I did is I made that method synchronized. See how we are making a thread or making a method or declaring a method as synchronized method by using the keyword synchronized. So whenever you have to declare a method as synchronized, use the keyword synchronized, then the return type, then the method name, then write all the content that we have to write inside that method. So here this print count is actually a method inside the class print demo. So if you want to access this method, even if it is synchronized, if you want to access this method that is inside the class print demo, we need to create the object of class print demo, and that is what we have created here. Here print demo PD is actually an instance or a reference variable of class print demo. This is not an object so far. Okay, this will be an object when we have written, when we write PD is equal to new print demo. So it is working like this. Inside this class test thread we have the main method, because a Java program, if it needs to work, there has to be a main method. So this entire program consists of three classes altogether. One class is print demo, the other class is thread demo, and third class is test thread. But the main method is only inside one class, that is test thread. So when we start executing this program, it starts functioning or it starts running from this main method, that is from this class test thread, because it is inside this class we have the main method. So it will start executing from this line. The first line, as you can see, it is creating an object of class print demo. Object name is PD. Print demo PD equal to new print demo. So now this PD is actually an object of class print demo. Which is that class? Class is this one. So we have created one object of that class here. Then I am creating two threads. That means we are creating two objects of class thread demo, because it is this class which have extended the class thread. That means thread demo is actually the thread. So we are creating two threads, T1 and T2, and see we have used the constructor of class thread demo. We are passing two parameters. One is a thread name and the other one is the object that we have created of class print demo. So when this line gets executed, we are actually calling the constructor of class thread demo. So you can see the constructor is here. The constructor is having two parameters. They are string name and print demo PD, where PD is actually a reference variable of type print demo. We need this second parameter to be a reference variable of class print demo, because we are actually passing an object of class print demo here. So for collecting or for capturing that object, we need a reference variable of that type. Here the type of this PD is class print demo. So for collecting or capturing an integer, we need an integer parameter. Similarly, for collecting a reference variable of class print demo, we need a reference variable of print demo itself. That is why we have written print demo PD here. So when this constructor is executed, we are calling this constructor, we are passing the name and we are passing the object. Now this PD is actually the object of class print demo. Similarly, when for creating T2 also, we will be calling the same constructor. We will be passing the thread name as well as the object. Then see what happens. T1.start. So we are actually starting the thread T1. So when we call this method, it's actually the run method that gets executed. And inside the run method, what we have done? We have called the print count method. So what's the purpose of PD here? We need PD to call the method print count, because PD is the object of class printdemo. Without using the object of a class, we cannot call a method. Print count is actually a method inside the class printdemo. So to call this method, we need the object of that class. That is why we have created PD here. So we are calling p.print count. Then we have print. So when this method is invoked, it is actually going to this method, doing all these things. It will come back, and this line will be printed. But since this method is declared as synchronized, first, since T1 have called print count, T2 will not be able to call print count because now T1 is using this method. Now, as long as T1 stops working, T2 cannot use this print count because this method is synchronized. So at a time, only one thread can access this method. See, you can see the output here. Okay. 5, 4, 3, 2, 1. That is of T1. Then again 5, 4, 3, 2, 1. That is of T2. Okay. And then thread 1, thread 2 is exiting and thread 1 is exiting. It will be printed here. So that's the purpose of a synchronized method. So once we have declared a method as synchronized, even if we have multiple threads, only one thread will be able to access that method at a time. One thread completes its functioning or its usage of that method, then it will move out of that synchronized method. Then next thread will enter into that monitor or will access that synchronized method. Then all other threads will have to wait. So there will be a queue of threads. Otherwise, what will happen? They will access it parallelly and the problem of data inconsistency may occur. So this is an example for synchronized method. So here we have converted a method as synchronized. The next example we are going to say is we are converting a block as synchronized. Both of them are different. Here we have created a synchronized block. So here see the method. It's the same method we have used in the previous example, but now it is not synchronized. It's a normal method. But what we have done is we have created a synchronized block here. So inside this block, that is inside this curly brackets, only one thread can enter at a time. The remaining threads will have to wait as long as the current thread moves out of this block. Previously we made that concept here, that is we made this method as synchronized, so only one method can be inside this method at a time. Now there is change, that is we have converted this block as a synchronized block, so only one thread can access this line at a time. So when I call t1.start, t1 will be entering this block pd.print count, that is we are actually invoking the method print count of class printdemo. So since t1 have invoked this method, t2 will have to wait as long as t1 completes its work. So the output remains the same, but the concept is different. In the previous example we converted this method as synchronized. In this example we are converting a block as synchronized. We are creating a new block. This block was not there. We created a new block which is synchronized. So only one thread can access or can be there inside this synchronized block. So that is how we perform synchronization in Java. So whenever you are asked to create threads in Java, keep in mind what we have to do is we have to create a class. So if the question is like you have to create two threads, then what you have to do is you have to create two classes, and both classes must be either extending class thread or implementing runnable interface, because these are the two ways in which we can create threads in Java. So either extend the class thread or implement the runnable interface. Then write the run method, because whenever we start a thread, it is actually the run method that gets executed. So we had to write the run method inside which we had to write all our contents. So that is all we need. I hope you understood. That is all in this video. Thank you so much.